Okay, so we're looking at this stable log rearrange problem. Let's look at my solution for doing it. So let's first look at the main function. So we read in the number of log entries, and then we will read in each line. And I have a new class called entry, which is for storing information about all the log entries. So I have a vector of this entry. So the goal is to use the built-in sort function to sort the entry for us. But of course, because of the order we want is very peculiar, so I need to provide a function for comparing two log entries. So there is this function for comparing two log entries that are provided. So then the main function is very straightforward. We read in a line of text, and then I'm going to create a new entry using this line of text. So this is constructor will do that. And all I'm doing is just add that to the vector. And then I sort it, and then I print it out. So that's all there is to the main function. So now let's look at this class of entry. So here I use this class as I'm really just storing all the data related to the entry together. I'm not doing anything fancier. So therefore, to make all my other code easier, I actually don't. I actually declare everything to be public. So all the variable here are public. So then I can directly use them in my main function to print, or in my comparison function. So because of that, so what I'm storing is first I store the text, the full string, the full line of the log entry, because I need to print it. So rather than reconstructing it, I just simply store that string. And I want to store the ID, and then I want to store a vector of string for the word inside the log. And in order to sort the digit entry, I also store a entry ID, which is based on the order it is added. So to make my code slightly easier, I also have a Boolean variable whether this current entry is a digit entry or not. And in order to construct this, to assign value to the entry ID, I have a global counter, which is declared to be static, meaning that there's a single copy of this variable for the whole class. So this is not a, I don't have a different counter for a different entry. Each entry object, they all share the same counter value. So it's similar to declaring this variable outside the class. So then, given a string, which is a one line for this entry, I first copy that string to the text so that later I can print it. And then I increment the counter and then assign the current value to EID. So this way, every new entry will get a new EID, which is based on the counter. So first what I'm doing is I find out the first word, find out the first white space, and then I use the substring sub-str function to create a substring of the starting from the first and then ending at the first white space. So this is the ID, and this substring will create a new string object, which is only used here. I'm not going to use this string object anywhere else. So therefore, instead of doing assignment, which will make a new copy of that substring and assign it to here, and then the old substring will be discarded. So instead of doing that, I simply use a move. So this will avoid creating a new copy of the string, and simply use whatever that string and assign it to here. So using move avoid making a duplication of a string and then discarding the original. So you can use move when you know the original will be discarded anyway. So and this is it's possible that you use move sometimes things goes wrong. So I don't really recommend it to use it. But you should use it only when you know the original object here will never be used again. But if you don't use it, it's just wasting a little bit of resource. It's okay. So you can it's totally fine to program without using move for the CP contact. So then I do the next thing to determine whether this is a digit entry or not. So I find the next non-white space character, and then if it's a digit, then this whole entry is a digit entry. So I use a built-in function isDigit to test whether the character is a digit or not. So I could write this myself using one line. But comparing with character 0 and character 9, but since there is, we can use this. And then the rest of them is pretty straightforward. Just parsing by, this is similar to the split function in the previous example. The only thing I guess is different is I create a substring, I use move again to push that into this vector of words. So that's all there is. Given a string, this part parse that string log entry into these different fields that are stored here. Then the only thing, so actually this line is not needed. No, actually this is needed. Yes. So there's another thing, peculiarity about C++. I really want to do this. Just say initialize this to be 0, but C++ doesn't allow that. So the compiler will complain. So I checked it up. It's actually I think it's a more legacy issue. It's they could allow this. It should be fine, but they chose not to. So then I have to initialize this outside, having say I want to assign counter to 0, but the counter is actually inside the entry class. So this entry class counter variable, I want to assign that to 0. So this is executed just once. So the only other thing that we need is to write the comparator comparing two entry object to give an order. So the way sorting works is the comparator should should implement a less than. So it should return true. Returns true when A is less than B. So then you can detect the equality by first comparing AB and then compare BA. If both of them return false, then you know they must be equal. So this is what the sort function require is this less than function. So how do I implement that? First, it depends on whether this is digit entry. If A is digit entry, then if B also is digit entry, then it's decided based on their EID, based on their time they add. So based on the EID. So else then A is the digit entry, B is the word entry. Then A should come after B. So the letter entry, all the letter entry come first. So that should return false. So A is considered to be bigger than B. Otherwise, A is at this part, A is a letter entry. Now, if B is a digit entry, then I should return true because a letter entry should always be less than a digit entry. So at this point, I have both of them are letter entry. So then what I do is I loop through all the words. So while they both have words, so when they both have words, I will compare these two string words. So I use the compare function, but the compare function does something slightly differently from this. So compare function will return a value less than 0 if A is less than B. It will return 0 when A is equal to B, or when this string is equal to this string. It will return a value greater than 0 when this one is bigger. So I will need to check if it's A is less than B, then I will return true. Otherwise, return false. Otherwise, I will checking the next word. So if the first word are equal, I check the next word. And if I'm done with this loop and I still have not decided which one is bigger, then that means the parts that are common, all the words are the same. So then I will need to check which one has fewer words. If A has fewer words, then A is less than B. Otherwise, if A have more words, then A is greater than B. If they have the same number of words, then I have to use comparing their ID. And if the ID is less than 0, that means A is less than B. So it is a little bit complicated, but I can put in all the comparison logic here, and then the rest of the code is fairly straightforward. So I guess the main lesson is you should when you encounter similar problem, you should think of using a class for the entry, and then create a separate comparator which isolate the complicated comparison logic. So I think compared to other problems that we use here, this is a kind of problem that probably more similar to what problem you would actually incur in real world to handle things like that. It doesn't really require very original thinking or problem solving ability, but you choose the right design. The code is simple and easy to understand. If you are choosing the wrong design, the code can be fairly messy.